talk about salts, and the first thing that comes to our mind is the salt that we use in cooking. It is chemically known as sodium chloride and is one of the most common compounds of a category, salt. A salt is an ionic compound formed by the complete or partial replacement of the hydrogen ion of an acid by a metal or basic radical. In sodium chloride, the hydrogen ions of hydrochloric acid are replaced by the sodium ions, cations of sodium hydroxide. Another example is the reaction of sodium hydroxide with sulfuric acid, where the complete replacement of the hydrogen ions of sulfuric acid with the sodium ions of a base results in the formation of sodium sulfate salt. On the other hand, the partial replacement of the hydrogen ions of the acid results in the formation of sodium bisulfate salt. Salts can be classified into 6 types: normal salts, acid salts, basic salts, double salts, mixed salts, and complex salts. These salts, formed by the complete replacement of the hydrogen ions of an acid by a metal ion or basic radical, are called normal salts. Sodium chloride, sodium sulfate, potassium sulfate, and sodium phosphate are some normal salts. Salts formed by the partial or incomplete replacement of the hydrogen ions of an acid by a metal or basic radical are called acid salts. Sodium bisulfate, potassium bisulfate, and sodium bicarbonate are some acid salts. Basic salts are the salts formed by the partial replacement of the hydroxyl groups of a diacidic or triacidic base by an acid radical. For example, in the formation of basic copper nitrate from copper hydroxide and nitric acid, the hydroxide ion is replaced by the nitrate ion. The crystallization of a mixture of 2 apparently saturated compounds, which lose their identity when dissolved in water, forms double salts. For example, when the saturated solution of potassium chloride and magnesium chloride is evaporated, a double salt known as carnallite is formed. Salts that contain 2 or more acidic or basic radicals other than that of a hydrogen ion or a hydroxide ion are called mixed salts. Bleaching powder or calcium chlorohypochlorite contains 2 acidic radicals, hypochlorite and chloride. Salts that are formed by the crystallization of a saturated mixture of 2 simple salts, but retain their identity when dissolved in water, are called complex salts. Complex salts, on ionization, produce 1 simple ion and 1 complex ion. The complex ion does not ionize into its constituent ions. For example, the crystallization of potassium ferrocyanide salt produces a simple ion, potassium, and a complex ion, ferrocyanide. Certain salts exhibit colors and may look very bright and attractive in colors ranging from white to metallic lustrous. However, a majority of the salts are colorless in the solid state and yield colorless solutions. Some salts commonly used in the laboratory are bright blue copper sulfate pentahydrate, bright green nickel chloride hexahydrate, sea green ferrous sulfate, yellow sodium chromate, bright orange potassium dichromate, purple potassium permanganate, and the salts of manganese like the black manganese dioxide, light pink manganese sulfate, and bright pink manganese chloride. During a reaction, the cations in a salt react with some reagents and form insoluble precipitates with definite color. This helps us in identifying the cations present in the salt. Plumbus, in its colorless salt lead nitrate, reacts with sodium hydroxide and forms a white insoluble precipitate of lead hydroxide. This precipitation is soluble in an excess of sodium hydroxide. The reaction of lead nitrate with ammonium hydroxide forms a white precipitation of lead hydroxide. Cupric, in copper sulfate, leaves a pale blue precipitation of copper hydroxide when it reacts with sodium hydroxide. Copper sulfate forms a pale blue precipitation also with ammonium hydroxide. This precipitation is soluble in an excess of ammonium hydroxide to give a deep blue solution. Ferrous sulfate is a green salt with ferrous ion. It forms a dirty green precipitation of ferrous hydroxide with sodium hydroxide. The same dirty green color precipitation of ferrous hydroxide is formed also when ferrous sulfate reacts with ammonium hydroxide. Zinc ion, in colorless zinc sulfate, reacts with sodium hydroxide and ammonium hydroxide and leaves a white gelatinous precipitate of zinc hydroxide in each. Magnesium ion, in its salt, the colorless magnesium nitrate, reacts with sodium hydroxide and forms a white precipitate of magnesium hydroxide. Magnesium nitrate does not react with ammonium hydroxide solution at all.